Alright, in this video we're going to do another integration by parts problem, and this is going to be an example that basically seems a little loopy. It feels like you do something and it doesn't make any progress, but in fact you're making perfect progress. So kind of a typical, I think, instructive example on this idea using integration by parts. So definitely something, if you're a calculus student, I think you'll want to kind of commit to memory and keep in mind. So here we're going to integrate e to the 2x times sine x dx. Again, I just wrote the integration by parts formula over here on the right. The integral of u dv equals uv minus the integral of v du. Alright, in this case we have to pick u. From that we'll get du. We've got to pick dv. From that we'll get v. There's a couple little rules on, how you pick your u. A lot of times I pick u to be the thing that when I take the derivative of it, it becomes more simple. Well, if I take the derivative of e to the 2x, I'm going to have to use the chain rule. I'll get e to the 2x times 2. That doesn't really seem much better. Likewise, if I let u equal sine x, I just get cosine x. Again, that doesn't seem much better. But we'll have faith and see what happens. So I'm going to let u equal e to the 2x. Again, by the chain rule, we'll get e to the 2x. We've got to multiply by the derivative of the upstairs part. So we'll get 2e to the 2x. dx is our derivative. Our dv, we'll simply let that be sine x. And if we integrate sine x, we get negative cosine x. I guess technically I should tack the dx onto the dv part. Alright, so it says, hey, if we integrate this, it says we're going to get u times v. So I'll pull the negative out front. E to the negative e to the 2x times cosine x minus the integral of v, which is negative cosine x. So if I pull the negative out front, so v du, I'm going to pull the 2 out front as well, and I'll be left with e to the 2x cosine x dx. Okay, so there's my v du stuff, kind of simplifying it all down at once. Alright, well, I went from e to the 2x to basically e to the 2x cosine x. And, at this part, I stop and think, well, what's going to happen if I do this again? I'm going to get back to probably e to the 2x sine x. Well, is that good? Let's see. So again, I'm going to pick u to be e to the 2x. Just like before, the derivative of that is going to be 2e to the 2x. We'll let dv be cosine x dx. And when I integrate that, we'll simply get sine x. Okay, so again, I'm going to put my integral in some brackets here, just so I distribute things properly here in just a second. So the first part we're done with. It again just kind of comes along for the ride here a little bit. So it says we'll get negative e to the 2x cosine x plus 2 times the integral of u times v. So I'll get e to the 2x times sine x minus the integral of v, which is sine x, times du. Again, I'm going to pull the 2 out front. So we'll get 2e to the 2x times sine x dx. Okay, if I distribute things out then, it says we get negative e to the 2x cosine x. If I distribute my 2, I'll get plus 2e to the 2x sine x. And if I distribute, again, the positive 2, I'll get negative 4 times the integral of e to the 2x sine x dx. Okay, so it seems bad in the sense that, or I don't know, maybe it seems bad in the sense that, the original thing we started with that we're trying to integrate, the e to the 2x sine x, well, hey, it cropped back up. So are we really making any progress at all here? And the answer is absolutely. So really what we have at this point, let me erase everything else except for my very last line. And get rid of my integration by parts formula. Okay, what we've shown at this point then is that the integral of e to the 2x sine x dx, what we've shown is that equals everything at the bottom, which is negative e to the 2x cosine x plus 2e to the 2x sine x minus 4 times the integral of e to the 2x sine x dx. Okay, so that's what we've shown at this point. Well, the idea is we can get rid of this integral on the right-hand side by simply adding it to both sides. So I'm going to add 4 times the integral of e to the 2x sine x dx to the right side, which means I got to do it to the left side as well. E to the 2x sine x dx. Well, if I have one e to the 2x sine x and I add on another 4 of those, what I have on the left side now is 5 e to the 2x sine x dx. And notice on the right side, hey, there's no more integral now. We have negative e to the 2x cosine x plus 2 e to the 2x sine x. Well, hey, we're there now. The only thing I have left to do is I could simply multiply both sides by 1/5. I could multiply the left by 1/5, so I'll have to multiply the right side by 1/5 as well. And then on the left side, we'll simply be left with the integral of e to the 2x sine x dx. On the right side, I'm going to pull the 1/5 out front, and I'm just going to leave the inside alone. Minus e to the 2x cosine x plus 2 e to the 2x sine x. And now that there's no more integrals left on the right-hand side, I guess technically I could have done it up here, I'm going to tag on my plus c because it is an indefinite integral in this case. So, you know, if you wanted to, you could even factor out another e to the 2x. I don't know if that's good or not. Probably if you wanted to see it in truly simplified form, that's what would happen. So I'm going to pull out, there's an e to the 2x and an e to the 2x, so I'll pull out the e to the 2x. Again, it's kind of, my pen's running out here. Try to rewrite it one more time. E to the 2x. Okay, and then on the inside the parentheses, I'm going to reorder things. I'm going to write it as 2 sine x, and then I'll be subtracting away just cosine x plus c. And that is now my antiderivative of what I started with. So again, kind of I think a very typical and instructive example to know when you do integration by parts. So I hope this example helps. Probably not the first integration by parts problem you'd want to look at, but if you have any questions, just either post a comment on the video or shoot me a message via YouTube. If I have time and I can, I'll try to help you out. All right, good luck out there.